Good afternoon, Math 30-1. Obviously, I'm not there in person today. I'm away for an appointment. But I did get some messages last night asking me to go over some homework questions. I'm going to do that here shortly. I also want to apologize. I was a day ahead of myself in my brain yesterday. We are not doing polynomial problems today. Today, you're going to be doing your class starter, and then you're going to be working on an in-class assignment. That will give you an opportunity to go through everything that we've done in this unit up to this point. So you're going to be working on that today after we go through these questions. So yesterday we were looking at the remainder theorem and the factor theorem. The remainder theorem says that if I plug a value into a polynomial expression and I get a number in the end, that number would be my remainder. And that would also give me a coordinate. So for example, this isn't the question for number 11, but if in number 11 I were to plug in, 2, and I got an answer of 8 at the end, my coordinate would be 2 comma 8. It would also mean that when I plug in the value of x being 2 into a polynomial and I get an answer of 8, that's no different than if I were to take that polynomial, divide by 2, and get a remainder of 8. So the x value is the x coordinate, the 8 would be the y coordinate, the 8 would also be my remainder. So p of x equals r. Now, if I sub in an x value and I get 0, that means that my remainder is 0, and that means that that will also lead to my factor. So if p of 2 were to equal 0, that means x minus 2 is one of my factors. All right, so the questions that I've been asked to go over are number 11, number 14, number 21, 22, and 24. So if there's others that you have questions about, feel free to message me or ask me in class when I'm back tomorrow. So for question number 11, it says, if the polynomial p of x equals x plus 2 times x squared plus 2x minus 1 plus k is divisible by x plus 4, then the value of k is. Now, some of you may want to go straight to synthetic division because that's what you're probably a little more familiar with. But remember, all of these questions can be done with the remainder theorem and the factor theorem. If something is divisible by x plus 4, that means that p of negative 4 is going to equal 0. So we can sub that information into our expression. So we'll have 0 equals negative 4 plus 2 times negative 4 squared. Remember, those brackets are important. Plus 2 times negative 4 minus 1 plus k. So we're going to multiply that out. Negative 4 plus 2 is negative 2. Negative 4 squared is 16. Minus 8 would be 8. Minus 1 would be 7. We'll just double check that again. 16 minus 8 minus 1. Yeah, so that would be 7. And then plus k. So we're going to have 0 equals negative 14 plus k. So k must equal 14. Now, of course, you're looking at these going, wait a minute, k equals 14 isn't even an option. That's because your teacher had a typo. So this should have said negative 4, negative 2, 0, and 14. So the answer is D. But of course, you wouldn't know that because you wouldn't know that I had a typo there. So I apologize for that. I will fix it for my notes for next time. But yeah, so if you got 14, you're totally right. I just didn't give you that option as an answer. So it says, what value of k would make x plus 2 a factor of this expression? Well, if it's a factor, that would mean that p of negative 2 is equal to 0. So we're going to sub in those values. We're going to have 0 equals 2 times negative 2 cubed minus 5 times negative 2 squared minus 2 times k times negative 2 plus 8. And then we're simplifying. So we've got 2 times negative 8 is negative 16 minus 5 times 4, so minus 20, plus 4k. Remember, we've got a negative and a negative makes a positive, plus 8. Now, when we simplify that, we're going to have 0 equals negative 16 minus 20 plus 8. So negative 36 plus 8 gives us negative 28 plus 4k. Moving over the 28, we're going to have 28 equals 4k. Divide by 4, and k equals 7. All right, taking a look at 21, it says the partial graph of a cubic polynomial function is shown below. When p of x is divided by x plus 2, the remainder is. Well, if I'm looking at x plus 2 as my factor, that means I'm considering p of negative 2. Looking at my graph, my x-intercepts are negative 1 and positive 1. So this is not a factor, meaning the remainder cannot be 0. When I look on the graph, p of negative 2 is right here. And if I follow down the graph, it's going to end up at some negative value. So the answer would be A. Now, even when I first looked at this question, my instinct was to go to making an equation. We could have said, well, I know that I've got x plus 1 as a factor because my 0 is negative 1. I've got x minus 1 as a factor to the degree 2 because it has a multiplicity of 2. And then there's an a and y, and I can plug in my y-intercept of 2, and I can go about solving for the equation and then plugging it in. That will still get you to the same answer, but remember that license plate above my desk. Keep it simple. P of negative 2, plug it in, work your way down, find that that's going to be a negative value, and that's all it's asking. So just a simple theory-based question. And if you're like me, you might have wanted to make it complicated at first. Moving on to question number 22. If p of x equals x cubed plus kx squared minus x minus 2, and p of negative 2 is 0, then factor completely. So we know that x plus 2 is going to be a factor, and that's where we can start. So we first need to figure out what our k value is. So we're going to plug in negative 2 and set that equal to 0. So we're going to have negative 2 cubed plus k times negative 2 squared minus negative 2. Don't forget that double negative, minus 2. So we're going to have negative 8 plus 4k plus 2 minus 2. So we're left with negative 8 plus 4k. So that means 8 equals 4k. Divide by 4, and k equals 2. Now that's just helping us finish off the polynomial. So that's going to give us x cubed plus 2x squared minus x minus 2. Well, we can use that and synthetic division to figure out the rest. Now, obviously, you can use your calculator. You can plug this into your calculator, find your zeros, and then you can do the rest of your factoring. But if you have to support your work algebraically, you're going to have to do the synthetic division. So we're going to have 1, 2, negative 1, negative 2, and we're dividing by negative 2 since we know that's a factor. So we bring down our 1. Negative 2 times 1 is negative 2. Negative 2 plus negative 2 is 0. We've got 0, negative 1, and negative 2 times negative 1 is 2. Gives me a remainder of 0. So that leaves me now with x squared minus 1, and that's what I'm going to factor, which is x plus 1, x minus 1. So this polynomial, when fully factored, is going to be x plus 2, x plus 1, and x minus 1. Moving on to number 24. So it says the polynomial function p of x can be written in the form x minus a times x minus b squared, and a and b are integers. We're being asked for the value of b. So if you're asked to do this as a written response question, you absolutely have to show all of your steps. But whether it's written response or whether it's numerical response, I would go to my calculator first. So I would type this equation into my calculator. So x cubed minus 7x squared plus 16x minus 12. And zoom standard. And then I'm looking for my zeros. Well, when you first look at this, it looks like it's a cubic function, which we can tell. but we can't see this far out or this far zoomed out where our zeros are. So there's one feature you can use called zoom box. So click on zoom, the first one is box. And what that does is it allows you to zoom in just on the area that we're focusing on. And once we're more zoomed in, you'll probably be able to see where your zeros are. And so we can see there's a U shape. So when we're zoomed out, it's kind of tough to see where those points are. We can draw a line at y equals 0. Or again, you could use your table of values to find out where your zeros are. Second calc 5, enter, enter, enter. This one has an intersect of 3. I'm suspecting that one's 2, so I'm just going to trace it 2. And that would be there. Again, you can use your table of values. You can go second function table. And when you're looking at your x values, you're looking to see where your y's are 0. So I have a 0 at x equals 2, and I have a 0 at x equals 3. So I know that when this graph was drawn, it kind of went up and down. And this was at 2 and this was at 3. My multiplicity of 2 happened at x minus 2. So my factors are going to be x minus 3 and x minus 2 squared. So the value of b would be 2. Again, if you had to do this algebraically, you could go about using those zeros to do your synthetic division or use your remainder theorem to find that answer. But our answer is going to be 2. All right, so those are the questions that people had sent in and asked me to go over. If there's anything else you're struggling with, feel free to send me a message or ask me in class tomorrow. Have a great day, guys, and I will see you soon.